This is Astro shot number 2. Heelstone, a relic from before the tilt. This Astro shot ties in with the first one, my shot at the Zodiac debate, where I mentioned an upright axis. Okay, let's get right into it. When looking at Stonehenge, if you observe it very carefully, you'll notice that geometrically speaking, something is off. What do I mean? If you were to design and construct an astronomical observatory in stone, you would undoubtedly take into account the four cardinal solar points, namely the two equinoxes and the two solstices. The reason is obvious, is because these 4 points are the main points easily marked along the horizon. When viewed from a single central point, you would first place an equinoctial marker to the east, with solstice markers symmetrically on either side. The summer solstice to the north and the winter solstice to the south. Now, that is not the case with Stonehenge. Its main axis, running from the center of the circle to the slaughter stone and the heelstone in the avenue, is pointing to the summer solstice sunrise. But to view the sunrise at the winter solstice and the equinoxes, you need to leave the central point, and you even need to leave the stone circle to find two stones that line up to either the winter solstice or the equinoxes. Where is the logic, or where is the symmetry in that? The least we can say is that Stonehenge is not very user friendly if you cannot view from one central point the four cardinal solar points. Now, Thomas Mills suspects that originally Stonehenge was lined up with the spring equinox sunrise and not to the summer solstice sunrise as it is now. This has a huge implication, for if the sunrise has changed position, it means that the Earth's axis itself must have tilted, and that human civilization was present when this cataclysm occurred. A second indication that the Earth's axis may have shifted, apart from the symmetry or the lack of symmetry in Stonehenge, is the age and the appearance of the axis stones. So, if Thomas Mills is correct, there must be something unusual about the stones on the main axis that are now lining up with the summer solstice. They must be way older than the other stones at the site if we want to build a case that they were at the site before the tilt. And this is exactly what Mike Pitts discovered. He's one of the few archaeologists who excavated around Stonehenge. It's his conviction that two of Stonehenge's largest stones had been in place at the site for millions of years before even the Neolithic people built the monument. Evidence of this are two pits in the ground, one of which may possibly have held stone 16, and the other pit is located near the heelstone. Mike Pitts believes the stones were dug up from the site and were not moved to the location like the other stones. It cannot be a coincidence that these stones they look undressed, uncarved. They don't seem to be carved or shaped in any way. Well, maybe it just appears they were not carved or dressed in any way. It's possible that there's another explanation for it. It might very well be possible that those stones, I'm talking about the slaughter stone and the heel stone, had indeed been chiseled at one point and are the oldest construction at Stonehenge, but then because of the actual tilt and because of the cataclysmic events during that tilt, they were eroded. And that's what we see. Like the slaughter stone, it fell down, it's lying flat on the ground, and the heel stone, it has holes in it. It's so eroded. It has holes in it that you can look from one side to the other. This explains why these elder stones are only found on a single line. For when the earth was upright, there was no declination. and therefore there were no solstices to mark. The sun and all the planets every day rose exactly in the east, above the heel stone. It is my hypothesis that after the tilt, a new generation of stargazers or astronomers or whatever you want to call them added more stones to mark the solstices and the other planetary declinations. And then they made the actual circle, and it was indeed continued to be used as a celestial observatory. And that they kept the slaughter stones and heel stones as a memento of the equinox's direction before the tilt. Of course, it's a convenient twist of fate that Stonehenge's axis, which was once pointing to the equinox, is now pointing towards the summer solstice sunrise. Well, actually, no, it's not a coincidence. When an upright axis tilts, that which had been pointing to the east before will now be pointing to one of the solstices. I'm sure there exists astrological software or astronomical software that can easily verify this. So that is why some of the most ancient megalithic sites, which are now pointing to the solstice, may originally have been pointing to the equinox. A few examples are Wan Mon in western Wales, Rujm el Hiri on the Golan Heights in Israel, and Nabta Playa in Egypt. They are all pointing now to the summer solstice, but it may well be, and it would be more logically and symmetrically beautiful, that they had been pointing to the equinox. In the southern hemisphere, of course, things are different than that which had been pointing to the east before the actual tilt is now pointing to the winter solstice. And I'm thinking of the geoglyphs near Cerro del Gentil in Peru. Some people, some researchers and archaeologists or historians, they claim or believe that Stonehenge never was a celestial observatory. I do not agree with this, if only because Stonehenge resembles a very famous celestial observatory instrument that can be found in India. It, with all its upright stones, it resembles the Ram Yantra. And simplified, this is how I think how the ancients must have used Stonehenge. And then I'm talking about, after the Earth's axis had tilted and they constructed the stone structure as we now know it. To determine a planet's longitude, those astronomers would have looked at a sign near the ecliptic and calculated its distance to a fixed sidereal star in the constellation of Aries. Actually, there was no need to measure it to the first point of Aries, because to determine a planet's sidereal longitude, you merely needed to measure its distance to one of the several fiducial marker stars near the ecliptic. For example, the ancients knew very well that Aldebaran was located in the center of Taurus and Antares in the center of Scorpio. Second, to determine a planet's declination, they must have looked at a point it was rising on the horizon in relation to the equinox marker, which of course would have been pointing straight east to 0 degrees of, in this case, tropical areas. They may not have known a planet's exact declination degree, but that doesn't matter. The main thing was to know the quadrant the planet or the celestial object was in. For this, they had to know two things. First, whenever a planet is moving north along the horizon, its declination is increasing. When it is moving south, its declination is decreasing. Second, whenever a planet is rising left of the equinox marker, it has a positive declination value, meaning north of the celestial equator, and when it is rising to the right of the equinox marker, it has a negative value. south of the celestial equator. As you can see on this Photoshop picture, so this picture is not quite accurate in the sense that you see the equinox marker, the heel stone, and I've used this picture as if the heel stone is pointing to the east, while now, of course, it is pointing to the summer solstice. Visually, this